Hello students, welcome to today's lesson where we are going to look at identification of charge, conductors and insulators, and this is under the uses of electroscope. We start with the first one, detecting the presence of charge on a body. Now, a charged body is brought near the cup, and when it is brought near the cup, it will cause the leaf to rise or to diverge. But if the body is uncharged, the leaf does not diverge. That is, you can be able to tell whether a body is charged or uncharged. Then number two, we have that electroscope can be used to measure the quantity or the amount of charge on a charged body. If a body being tested has little charge on it, the leaf of the electroscope will diverge a little. And if the body has a lot of charge, the leaf divergency will be more. That way you are able to know whether a body has little charge or not. Then number three, we have electroscope can be used to test the sign of charge on a charged body. In here we have that if a charged body is brought near the cup of a charged electroscope, the leaf of the electroscope will diverge more if the body and the electroscope have similar charges. This is because there will be a lot of repulsion. If they maybe we are taking an example where a body is positively charged and the electroscope is positively charged. So if it is brought closer to this electroscope, you will find that there will be repulsion, and therefore you will find that the leaf will diverge more. But if the leaf, electroscope, and the body are having different charges, you will find that the leaf divergence will decrease, or in other words, you will find that the leaf will fall. Then we move to the next use, testing for charges. We have the first case. Charge an electroscope negatively and bring a negatively charged polythene rod close to the cup. Notice that the leaf diverges further. Note here that the rod is negatively charged and the leaf is not, or the electroscope is negatively charged as shown in this diagram. We have the negatively charged rod here and our electroscope is also negatively charged. So when it is brought closer, there will be repulsion. All the electrons from the cup will be repelled, and that is why we are having, there is the divergency of the leaf that is increasing, because there will be more negatives in both leaf or the gold leaf and the metal plate here. Then case 2 is where you bring up a positively charged acetate rod close to the same negatively charged electroscope. Note here that they have different charges. Notice that in this case the leaf collapses as shown in this diagram. If you look at this diagram, we have positively charged rod. When you bring it closer, all the negatives from the leaf and the metal plate here will be attracted to the cup, and therefore there will be no charge here. That is why we are finding that the leaf falls when the two, that is the rod and the electroscope, have different charges. Then the case number C, we have that place your hand on your uncharged metal rod close to the charged electroscope. Notice again that the leaf collapses. Notice that here the metal is a good conductor of heat, of charges, or it is a good conductor, and therefore it can make the charges to flow through it, through your finger, thus discharging the electroscope. So in these two cases, that is part B and C, they are giving us the same results, that is the leaf is collapsing. Therefore, we can say that collapsing of the leaf is not evidence for the presence of a charged body. Remember, in our case here, we are testing for the charges. And therefore, we can conclude and say that only the divergence can tell us that a body is charged. Then we move to our explanation here. When a strong positive rod is brought from high position towards a negatively charged electroscope, the leaf divergency first decreases, then increases as the rod approaches the cup. Why? The leaf divergency reduces slightly first because the positives or the positive charges on the rod attract the negative on the leaf and the plate, making the electroscope neutral. But on moving the rod much closer, the leaf divergence increases again to a higher position. This is because the strong positive rod attracts more electrons from the plate and the leaf, making them more positive. Hence, they repel further. That way, they are able to increase the divergency. Then the same observation are made when a negatively charged rod is brought towards a positively charged electroscope. Note here we are saying negatively brought close to positively. Here we are talking of positively brought close to negatively. On moving a neutral conductor close to a charged electroscope, neutral means that it has no charges, the leaf divergence decreases. Charges on the electroscope induce opposite charges on the conductor. Then we can therefore state the rule for testing a charge as follows. 1. If the leaf of the charged electroscope diverges further, when a body is brought closer to the cup, then the body is charged. The sign of the charge on the body is the same as on that electroscope. So if the electroscope is negatively charged, then the body is also negatively charged. Then number 2, increase in divergency is the only sure way of testing the sign of charge on a body. The table below shows the summary of the results obtained when we are testing the sign of a charged body. We have that if you have a positively charged electroscope and then a rod of positive charges is brought closer, then we have that the leaf divergence increases. The same case is applying when you have a negatively charged electroscope and a negatively charged rod. But when you have different charges, that is, you have positive electroscope or positively charged electroscope and negatively charged rod, or negatively charged electroscope and positively charged rod, the two are giving a similar result, that is, the leaf divergence decreases. But in our last case here, when you have a positively or negatively charged electroscope and then you are working with uncharged body, you find again there is a decrease in divergence of the leaf. So in this case, you can be able to see that these three, we have similar results, and therefore the decrease of divergence of the leaf cannot be used to test the sign of the charge on a body. So increase, the way we have said, increase in divergency is the only sure way of testing the sign of charge on a body. Then we move to testing the insulating properties of an object. That is, we want to test whether a body is a conductor or an insulator. In this case, we get, first of all, to charge the electroscope and then bring the object to the top of the electroscope and add the electroscope. Materials like copper, iron, aluminium, zinc, and graphite make the leaf divergence decrease. Why? Materials like plastic, glass, wood do not affect the divergence of the leaf. Again, you need to ask yourself why. The reasons are here. For metals and graphite, the leaf decreases in divergence because they allow electrons to flow between the electroscope and the earth, the process that we call earthing. Such materials are called conductors. They are allowing charges to flow through them. And they allow the charges to flow through them because they have free electrons, or what we call delocalized electrons. That is, these electrons are able to move from one atom to another. And that way they are able to move from cup of the electroscope to the ground. For materials like plastics, glass, and wood, there is no change in leaf divergence because they do not have free electrons, and therefore they cannot allow electrons to flow through them. In these materials, the electrons are not free and they are strongly bound to their nuclei. Such materials, we call them insulators. So we are able now to differentiate between conductors and insulators. Conductors can allow charges to flow through them, while insulators cannot allow charges to flow through them. Now, there are other materials like silicon and germanium, which are conductors under certain conditions. For example, at normal conditions, these materials behave as insulators. But when you increase the temperature, these materials behave as conductors. So you can change their conductivity by varying or changing the temperature. So these materials, we call them semiconductors. And their conductivity lies between that of conductors and insulators. Then we move to the charges in air. One thing that you're supposed to note is that air can be charged using two ways. One, by heating, and two, through radiations. The presence of charges in air can be shown using electroscope. How do you use electroscope? You only need to heat the air above the cap of the electroscope and see the behavior or observe the behavior of the gold leaf. It is observed that the leaf divergence decreases. That is when you heat the air. When a fuel burns, chemical reactions yield ionized products. The ions, remember, ions are either positively or negatively charged atoms. So these ions move and collide with air molecules, and these air molecules are thus ionized. And when they are ionized, we will produce what we are calling the positive or negative and the negative charges. The positives will be either attracted or repelled by the electroscope. Now, for example, we are saying the ions carrying opposite the charge of the electroscope are attracted. So in other words, we are saying if the electroscope was positively charged, it will attract the negatively charged particles. And this will result in discharging the electroscope. And that will make our leaf to fall. Then we move to applications of electrostatic charges. We have the first one, electrostatic precipitators. Then number two, we have fingerprinting. We have spray painting, photocopying. After that, we have the dangers of electrostatics. One, we have the sparks and fires. So when the fuel rubbing inside the pipe, when there is a rubbing, maybe we are talking of the fuel is moving through the container, and therefore there is rubbing, you'll find that there will be charges, or what we call the static charges, that are produced. These static charges can cause sparks, and these sparks can ignite the fuel, and you can be able to cause fire. So fuel in plastic cans generate charges as it rubs within inner walls of the can. It is therefore advised to store fuels in metal cans so that any charges that is generated can leak away, because metals are good conductors. So they can allow those charges to flow through them and leak away. Fast moving water jets become charged and may cause fuel tanks in store to explode while cleaning. Then we have the loose chain in fuel tanks is used to add the charges that are produced by friction between the moving parts of the vehicle. So whenever there is friction or whenever there is rubbing, there is formation of what we call the static charges. And these static charges can cause sparks, which in turn can cause explosion. And that is why now we have the loose chains in fuel tanks. These loose chains will allow now those charges to flow or to be added, and that will prevent the fuel from exploding. Then we have electric shock. If you walk on a nylon carpet, you always experience a shock when you touch a metallic handle of the door. This is because as you walk, there is friction, and that friction causes what we call static charges, and that static charges, as they try to move through your body, you feel or you experience the shock. Then we have a car radiator generates charges that can cause shock if touched. Those are the two cases where we have electric shock due to electrostatic charges. Then we have lightning. Under this we have electrostatic charges from lightning causes shock leading to death. We have seen many cases where people are dying due to lightning, and this is because the electrostatic charges that are caused due to the friction between the clouds, you find that they will try to move to the earth, and if they passes through your body, it can cause death. After that, we have the assignment. As you can be able to see, this assignment are testing all what we have learned So take your time, revise, and then you come and tackle your assignment. Make sure that you get everything. Finally, prepare for the end of topic exam. It has 10 questions, and apart from testing the concept of electrostatic, it shall also test your accuracy and speed. So make sure that you are fast enough to be able to complete the exam within the time that is given. So thank you, and may God bless you.